Good morning everyone. So today we are going to discuss the name reactions in organic chemistry. You know there are some reactions which have a name to them based on the name of the scientist or on the basis of the type of process. So in the series, the first name reaction which I am going to take up today is Wurtz reaction. And Wurtz reaction is basically converting an alkyl halide to an alkane. So let us start. First the name. This is the name of a scientist. This is Wurtz reaction, and the reaction is, let's make it very simple. We take an alkyl halide which we also call as a haloalkane, like I have taken chloromethane. So the first point to be remembered is you need to take 2 moles of this haloalkane and you need to put a small piece of sodium into it. So I am putting a small piece of sodium, I am writing it on the arrow, and it has to be put in presence of dry ether, and the result would be that we get an alkane where the 2 alkyl groups get attached. I hope you all understood. See, the alkyl groups, I'm just highlighting the alkyl groups with a green color. This was the alkyl group here, this was the alkyl group here, and they both got bonded with each other. And of course, the byproduct is going to be NaCl. That is simple, everybody must have predicted that the byproduct would be NaCl. So this is Wurtz reaction. Now comes the second question, and that is, are there any limitations attached to it? Yes, there are 2 limitations. This is a very important question asked many times. One very simple limitation which all of you can predict is that you cannot prepare methane. Cannot be prepared, can't be prepared. The reason being, methane has got only 1 carbon, and in Wurtz reaction the 2 alkyl groups are getting attached, so definitely the alkane formed would have more than 1 carbon. Second limitation is, it is not advisable to prepare an alkane containing odd number of carbon atoms. I'll just simply write this short form of the limitation: odd number of carbon atoms, not advisable. That this alkane shouldn't be prepared. The reason is, to prepare an alkane which contains odd number of carbon atoms, say for example I want to prepare propane, so let's prepare propane. Propane is having 3 carbons, CH3, CH2, CH3. Now to prepare a propane molecule, I will have to use 2 different alkyl halide molecules. Like I have to use CH3Cl, that would take care of CH3, and then I have to use C2H5Cl, which will be taking care of CH3CH2 part. I do the Wurtz reaction, like I put sodium, I put dry ether, but now the thing is, 2 molecules of CH3Cl will react together to form ethane, and 2 molecules of C2H5Cl would combine together to form butane, and then 1 CH3Cl and 1 C2H5Cl would combine to form propane. So in order to prepare propane, I ended up in 3 types of alkanes. Now the question is, it's okay, you got 3 types, but then why is it a problem? It is a problem because these 3 alkanes have got very close boiling points, so it will be very difficult to separate them by any method like fractional distillation, etc. Second problem will be that the yield of each alkane will come out to be very less. So it is not advisable to prepare an alkane containing odd number of carbon atoms. That was about Wurtz reaction. Let's quickly repeat in a nutshell what have we learned about Wurtz reaction. Wurtz reaction was, you start with a haloalkane I've put it as Rx. You take 2 molecules of it or 2 moles of it. You react it with sodium dry ether and you end up in an alkane of the type RR. Double the number of carbon atoms. Limitations were you can't prepare methane. Methane is not possible. Odd number of carbon atoms. If the alkane has odd number of carbon atoms, you can prepare it, but not advisable because it becomes difficult to separate the 3 alkanes which will be formed, and the yield of each alkane will come out to be less. So that was all about Wurtz reaction, and in the next video we'll take up another name reaction. Till then, please revise Wurtz reaction completely. Take care and God bless.